Hello, my name is David Ackerman, student number 220310629, and this is my MEC 2302 Dynamics assignment 10. Let's get started on explaining it. This is the question where it gives us a diagram and the whole setup. This is the givens that at 0, theta equals 0, the rotational at 1 equals 3, rad 3 per second, and at 90 degrees that we're looking for that. The mass at AB equals a mass at CD, which is 10, and the length of each rod is 0.3. Here is a diagram where I have the initial forces and then the final forces and all the forces acting on the object. So at first we need to use the conservation of angular momentum, where the force courses there's no moment at the z-axis, causing that the angular momentum at the z-axis is confirmed. So now we need to take the moment of inertia on each one, and then this is the calculation for the initial, where iz the moment of inertia at the z is at 1. For each rod is the addition of 0.3 of 0 and 0.1, which is 0.4 at 0 per second. At 0, theta equals 0 degrees. Here you add all the numbers up and you get that hz1 is 11.4 kilograms meters per second. And the final, very similar process where iz2 is this, so we substitute that into the n, and we plug it in, and we get that hz2 equals 0.2 omega 2, which that's the unit we're looking for. Here we're combining both of them, and we're solving for omega w2, which is 57 rads per second counterclockwise. Now when you use the work energy principle, which is T1 plus the addition of H1 and 2 equals T2. T1 is kinetic energy, so we're doing the same thing where IZ1, which is the moment of inertia, for each rod is the D equals 0.4. We're adding every single number up, and we get that the T1, the kinetic energy at T1 is 17.1 joules. The kinetic energy at 2 is this. We're adding up every single number that we know, including the omega 2 that we found, and then we get that T2 equals 324.9 joules, and the potential energy at work. The work is negative 58.86 joules. And so now we're combining all of them, and we get that the final answer is, we're plugging all the values, and we get the final answer is 366.66 joules. This has been my presentation. Thank you for listening.